are continuing with chapter 2 पोटेंशियल। जो पहला टॉपिक है पोटेंशियल ड्यू टू अ सिस्टम of charges. Let us suppose that we have this coordinate axis where we have a point P, coordinate axis x, y and of course z. We want to find the potential at this point due to a discrete charges Q1, let us say here it is Q2, Q3 and let us say here it is Qn. Now this Q1 has a position vector R1, this Q2 has a position vector R2, this Q3 has a position vector R3 and this Qn, let us say it is here, has a position vector Rn. ठीक है? Now let Rp be the position vector of the point of observation where we have to find the potential produced by these charges, n charges, discrete charges. Now the distance between Q1 and P is this. Similarly, distance between Q2 and P is this. Distance between Q3 and P is this, and Qn and so on. Now, we know that potential V1 due to charge Q1 at P is equal to 1 by 4 pi epsilon 0 Q1 and this distance R 1P. ठीक है? इसको ऐसे भी लिख सकते हो डायरेक्टली, ऐसे भी, या सिंपली इसको 1 by 4 pi epsilon 0 Q1 by R1. ठीक है? Next, now potential due to charge Q2 at P, that is V2, that will be again 1 by 4 pi epsilon 0 Q2, distance between charge Q2 and P, that is R2P. ठीक है? Similarly, V3 will be equal to 1 by 4 pi epsilon 0 Q3 by R3P and so on and so forth. Vn will be equal to 1 by 4 pi epsilon 0 Qn by Rnp. ठीक है? Now the total potential at this point due to all of these charges will be the sum, not vector sum, simple algebraic sum, because keep in mind potentials are scalar quantities. So total potential will be equal to V equal to V1 plus V2 plus V3 plus Vn. Now we have to simply substitute the value. We get total potential will be equal to, let us say, V, which will be equal to 1 by 4 pi epsilon 0 Q1 by R1P plus Q1 by 4 pi epsilon 0 Q2 by R2P plus dash plus 1 by 4 pi epsilon 0 Qn by R1n. ठीक है? इसको हम शॉर्ट में ऐसे भी लिख सकते हैं, V इक्वल टू 1 by 4 pi कॉमन निकल 1 by 4 epsilon 0 कॉमन निकल सकता है, तो यहाँ पर क्या होगा, Q1 R1P प्लस Q2 R2P प्लस dash प्लस Qn Rnp. ठीक है? इसको हम ऐसे भी लिख सकते हैं 1 by 4 pi epsilon 0 Qi Rip, where I runs from 1 to n. this is the final relation for total potential at a point due to discrete charge distribution. Okay. Next topic, electric potential at a point due to a continuous charge distribution. Suppose we have a volume V and this carries a charge. Okay, now since this has a charge, it means this has a volume charge density. That is volume charge density rho is equal to volume small let us say dq by dv, charge per unit volume. Now dq is an element whose charge is dq. Okay. Now let us suppose we take the coordinate axis and electric potential due to a continuous charge distribution. Let us suppose that we have a volume whose volume charge which has a charge over it and has a volume charge density rho. Okay. Let us suppose that we have a point P where we want to find potential due to this volume charge due to the whole of this volume charge. Let us first of all take the coordinate axis. Let us say this is y axis, this is z axis, and this is x axis. This is origin. We divide this whole volume into small volume elements dv. Okay. Let's suppose that this volume has a distance r from the origin, position vector, and this has a position vector of r. So that this volume element has a distance of r p minus r. Okay? Because we have applied a triangle law. This plus this is equal to this. So we will get this. Okay. Now, since this volume element dv has a charge, let us suppose it has a charge dq. Let us suppose this has a charge dq upon it. Now we know that volume charge density is equal to charge divided by volume. इस एलिमेंट की चार्ज डेंसिटी चूंकि इसकी कांस्टेंट है, so dq charge on this element divided by volume of this element. So total charge dq will be equal to rho, which is function of r, charge density, volume charge density into volume of this element. That will be charge on this element. Now potential at point P due to this charge element, we know that, let us say potential, it will be a small potential because of small charge, so it will be, let us say dV. Okay, this is small v. Okay, now potential dV due to this element, small element of dV is equal to, ये small v है वॉल्यूम के लिए, कैपिटल v है for potential. Now that is 1 by 4 by epsilon 0 q, मगर इसका चार्ज क्या है dq by r square, डिस्टेंस क्या है by r, that is rp minus r magnitude इसका. ठीक है. Now we will substitute the value of dq from this into this. So we will get dV, the potential, equal to 1 by 4 pi epsilon 0 dq के बदले में rho r into dq divided by rp minus r. Okay. Now, since ये छोटे वॉल्यूम का है, now we want to find the potential due to whole of this volume charge. So we will integrate it. So V total potential will be integral dV, which is equal to integral 1 by 4 pi epsilon 0 rho r लिखे, it is understood as a function of r dq divided by rp minus r magnitude, or sorry, this is rho dV. Okay, volume wala. Okay, sorry. So V, it can be also written as V is equal to 1 by 4 pi epsilon 0 rho on integral rho dV. Simply we can write it as, let us say, R. So this is a required potential, expression for the potential due to volume charge. Potential, here I mean electrical potential due to a thin conducting charged sphere. देखिए, let us suppose that we have a thin conducting sphere, hollow sphere. Okay. Now, let us suppose that Q is the total charge upon this and O is the center. Now we have to find the potential outside it. Let us say this is R at point P, and on it, when this is R, OA is equal to R, the radius of the sphere, and R, and inside it. Okay, inside, anywhere inside it. Okay. Now, we know that the charge on a conducting sphere behaves as in such a way that whole of the charge is concentrated at the center. Okay, it is already known. Therefore, if we assume that this whole of the charge which is on the conductor is at Q, center is at center O, that is Q, then what will be the potential due to this charge Q at this point P? That will be simply V is equal to 1 by 4 pi epsilon 0 charge is Q by distance is small this r. Okay. Now, this is outside, go outside. Now, if we decrease this distance and bring this point slowly and slowly, this potential will, this r will go on decreasing, potential will go on increasing. Finally, we will reach at this point on the sphere. So, anywhere on the sphere. So, potential on the sphere, potential on the sphere will be equal to 1 by 4 pi epsilon 0 Q by, now R किसके बराबर बनता है? R बनता है R के बराबर. So, this will be the maximum value. So this will be max, maximum value on the surface of this. Now, when we go inside the hollow sphere, electric field E is equal to 0. Now, electric field E is equal to 0. We know that dV by dr, okay, is equal to E or minus E. Okay. Now, as E is equal to 0, which implies that dV by dr is equal to 0, or by cross multiplication dV will be equal to 0. But dv means the differentiation of a constant is always 0, which implies that v is constant. ठीक है? So inside the sphere, hollow sphere, v is constant. So we get here यहाँ पर e